So let's take a look at example 2. So if we want to do component form, which is on your slides, we would write this as q1 minus p1, and then that's the first coordinate, and then q2 minus p2. So that would give us our component form. So we would write it like this. So let's take a look at example 2. So if I have P and Q, and like I said, if you want to view it as a right triangle and figure it out that way, that is fine. But if you don't have a picture in front of you, you're going to just plug it into the formula. So this would be P1, P2, Q1, Q2. So let's see in component form what it would be. So Q1 minus P1, let's see here, -1. So this is V1. So this space right here will equal this. So -1 minus 4 equals -5. And then V2 would equal Q2, 5 minus -7, which is 12. So in component form, we would write it like this, -5, 12. So that's component form. So if we now want to know the magnitude, which I forgot to tell you guys on the last problem, but if you want to look for magnitude, the way to denote it when you're writing, so if we have our vector here, if I want to know the magnitude of vector v, it would be written like this. This signifies that we're looking for magnitude. So we know it's -5 and 12, so if we wanted to just think of our distance formula, it's going to be -5 squared plus 12 squared, or you could sit here and do out the whole thing with your points, but since you already know the differences, you can do it this way. So 25 plus 144 equals the square root of 169. So your magnitude would be 13.